the 25x squared minus 4, it's the difference of squares again. It's 5x squared minus 2 squared. That's why I have the 5x plus 2 with 5x minus 2. X plus 3 just rides along. And the x squared minus 9, again, factors into the difference of squares because it's x squared minus 3 squared, which factors into x plus 3, x minus 3. Now, of course, now we can cancel, right? What can we cancel? And, oh, yeah, and the 5x minus 2, thank you. And what are we left with? Just 5x plus 2 divided by x minus 3. All right. So this is all, at the moment, everything I've done is from section 5.1, which I think is, well, it's a little bit easier than section 5.2, for sure. Let me show you a somewhat moderate problem in section 5.2 to end today. All right, we'll do more of these next time, obviously. But just to try to get you started to think about how these things go. Example 16, we could do something like this. 1 over x plus 1 minus x over x minus 2 plus x squared plus 2 over x squared minus x minus 2. So we're supposed to add these and simplify. So you've got to look for a common denominator of all three of these things, right? So the question is, what's the least common multiple of x plus 1, x minus 2, and x squared minus x minus 2? Well, okay, so a good starting point on something like this is just to kind of pick on the most annoying thing, which is this right here, right? And notice that x squared minus x minus 2 factors into x minus 2 times x plus 1, yeah? And so because it factors, that makes this analogous to something like the problem of adding 1/7 plus 2/3 plus 10 over 21. It's like that. That's the kind of pattern we have here. We have one factor 7, we have another factor 3. There's nothing common to them. But then the third fraction is actually the multiple, it's the common denominator for the first two, isn't it? So in the same way we would add these fractions, we're going to convert everything to 21sts, so to speak, by analogy. We're going to convert everything to 21sts. And so what that looks like here, sorry, I should have written that somewhere else. My bad. I'll continue down here. So we've got 1 over x plus 1, right? So I multiply by 1. I'm going to multiply by x minus 2 over x minus 2. And then I've got minus x over x minus 2. And I'm going to multiply by 1. But I'm going to multiply by the 1. That converts it to the same kind of fraction as the third one. So instead of multiplying by x minus 2 over x minus 2, multiply by x plus 1 over x plus 1, right? I can only multiply by 1, just like we're doing at the start of today. Just now we've got expressions rather than numbers. And then, well, the last one's already in the right form, x squared plus 2. I don't have to do anything to this. It just rides along. So what that gives me then is x minus 2 over x squared minus x minus 2, right? Minus x squared plus x over x squared minus x minus 2 plus x squared plus 2 over x squared minus x minus 2. We have now earned the right to add these because they have the same denominator, right? They must have the same denominator in order for us to add. But now we can, and we just add them by adding the numerators. So we've got x minus 2 minus, parentheses are your friends here, x squared plus x. Be careful, this is a common mistake. People forget to distribute the minus to both of the terms in the middle fraction, So beware of the minus and how it has to distribute if it's there. Anything cancel? Oh, yeah, the x squared is going to cancel with that x squared, right? And this gives me a minus x with that plus x. So this guy and this guy cancel. And whoa. Whoa. That's 0. Cool. That was unexpected. Well, there's a 2 and a minus 2, isn't there? Well, I'll write it fine. Let me x minus 2 minus x squared minus x squared plus 2, right? As you can see, this x and that minus x cancel. This 2 and that minus, there's 3 cancellations, right? And that gives you 0 over x squared minus x minus 2, which we just write as 0. Okay? This is number 63 in section 5.1, and the answer in my teacher's edition is 0, if that makes you believe it more. You know? It says 0 in the book. Argument by authority. People accept argument by authority, even if you don't accept mine. Anyway, thanks, guys.